Hello, so today we are going to discuss about the impulse response of a LC tank circuit. Now first let us consider this circuit. This is a simple LC tank circuit. Here inductor and the capacitor are connected in parallel, like at t is equal to 0 when this switch is closed they will be connected in parallel, and here we consider both inductor and capacitor are ideal or lossless, and the initial voltage across the capacitor is V naught. So at t is equal to 0 when the switch is closed, so what happened, uh, the total voltage, that is V naught, will also available across the inductor, and we know that the capacitor can't change its voltage instantaneously, and inductor can't change its current instantaneously. So initially total voltage across the both inductor and capacitor will be V naught. So as finite voltage is available across the inductor, it start gradually developing current, and capacitor voltage start decreasing, because here the only source of energy is the voltage stored in the capacitor. So from that, inductor try to gradually charge, so its current will gradually increase but the voltage of the capacitor gradually decrease. So the voltage of the capacitor gradually decrease here. When the voltage becomes 0, then the current through the inductor will become maximum, because the stored energy in the capacitor in form of voltage will now go to the inductor in form of current. Let me draw it in different color. So the inductor current will increase like this. So now what will be the value of the maximum inductor current? The energy stored by the capacitor, half C V naught square, is equal to half L I square. So this is the energy stored by the inductor. So I is nothing but V naught root under C by L. So this is the maximum amount of current. Now what happened? This amount of current I naught stored by the inductor. Now this will charge the capacitor in this way, in the opposite direction. So the capacitor will start charging in the opposite direction, and the voltage and the current stored by the inductor start reducing gradually. And what happened? The uh, voltage of the capacitor start increasing, but in the opposite polarity. Okay, so it will look like this. Now here the voltage of the capacitor becomes V naught here, and current becomes 0 here. Now the capacitor will charge the inductor in this direction. Okay, so the current will go in the opposite polarity, and the voltage of the capacitor start discharging or start reducing again. So the voltage will reduce and eventually becomes 0, but at that point the current in the inductor become maximum but in opposite direction. Similarly, this process will continue, and current becomes 0, and the voltage becomes V naught as initial. So this process continue. I showed it for one cycle, as here the inductor and the capacitor both are lossless, so this oscillation start continuing. But if they are not ideal, they are not lossless, then the oscillation can't go for infinite amount of time. And what is the frequency here? Frequency will be nothing but 1 by root under LC, as these L and C are combined together from a resonance circuit. I hope you understand. First, capacitor have some voltage. This will charge the inductor. When the capacitor voltage becomes 0, inductor current is maximum. So now inductor again start charging the capacitor, but in opposite polarity. So you can see when the inductor current is 0, the capacitor is maximally charged, but in opposite direction, right? So again capacitor charge the inductor, and again inductor charge the capacitor, and in this way this process continue. Now in this problem, the inductor and capacitor does not have uh, initially any stored charge, like initial voltage of the capacitor is 0 volt and initial current of the inductor is 0 ampere, but we have applied an unit impulse current, sorry, an impulse of current, phi of del t. So at t is equal to 0 plus, so the impulse arrived at t is equal to 0. So at t is equal to 0 plus, what happened? As this is an impulse signal, so it frequency tends to infinite. So the uh, inductor is behaves like a open circuit and capacitor behaves like a short circuit. So total impulse of current start flowing through the capacitor, and we know that if impulse of current start flowing through the capacitor can charge instantaneously. So what will be the voltage across the capacitor? So Vc of t is equal to 1 by c minus infinity to t ict dt. So 1 by c minus infinity to t. Here ic is, sorry, q del t dt. So it becomes q by c. So the problem is kind of similar. Here v naught is q by c. Then rest of the things is similar. Now in the next problem, suppose here instead of applying a single pulse, we are applying a pulse train, like the first pulse, which q of del t comes at t is equal to 0. The next pulse comes at t is equal to t on t, suppose, and the next pulse come at 2t. So what will be the response? Now if we look at the voltage response, so for this pulse, so what is the initial voltage? Q by c, let us consider as v naught. So this v naught will come in the output, then gradually it decreases, again it goes negative, after that it again reach to its previous value. As I discussed in the previous circuit, this white waveform, this is similar. I am not drawing the current waveform, you can draw it by yourself. Now again at t time interval, what happened? Another similar kind of pulse appeared. So due to this, the capacitor will again charge. Now the capacitor here charged to V naught voltage. Again V naught will come. So total 2 v naught. So now the waveform will start from this point. Okay, so it looks like this. Again, this amplitude increases double as compared to the previous one. It becomes 2 v naught. Again at 2t, again another pulse come, so it becomes 3t and so on. Sorry, 3 v naught and so on. In this way, this process continues. I hope you understand. Like um, as these pulse come at exactly at t. Here t is 1 by f, and f is the resonance frequency. If the pulse come at different position, then they may cancel out. We don't get exactly get this kind of waveform, right? Now let's see another example. Here initially a pulse come, so initially the waveform will look like this. Okay, now here please concentrate. Here the pulse impulse come but in the opposite polarity. So what will happen, due to this pulse another voltage waveform, another voltage generated across the capacitor, but this is opposite as compared to previous one. This will be minus v naught. So what happened, this is plus v naught and this is minus v naught, so both will cancel each other. So our equivalent output becomes 0 volt. So the voltage stored in the in the capacitor in this period is 0 volt. Okay, so no voltage stored in the capacitor, neither any current stored in the inductor. So the overall energy of the circuit becomes 0 here. Now again when another pulse come, again an waveform generated. Here the voltage of the capacitor becomes V naught, and this again start oscillate. Again when a negative impulse come, again cancel this out, and again it becomes 0. I hope you understand this. So this is the beauty of this circuit. Okay, so and all this happen because both the inductor and the capacitor are lossless. Now can you tell me like what will happen if I change the circuit in this way? Like this is our inductor, this is our capacitor, initially charged to V naught, and here a diode is connected. So what will be the voltage across the capacitor? Please try and let me know in the comment section, and if you have any doubt, please feel free to ask, and let us consider the diode is ideal for one case V gamma is equal to 0. Okay, and try to answer this question, and if you have any doubt, please let me know in the comment section. So thank you.